So let's get into it. An exponential function looks like this, where the A tells you the shape, what your graph should look like. B could either be greater than 1 or between 0 and 1. I would say it is what tells if your graph is increasing or is decreasing. The P tells you the shift of your graph, while the Q tells you the y-asymptote. There is only one asymptote in an exponential graph. This first picture shows you if your A is greater than 0, which means it is positive, and your B is greater than 1. An example of that is 2 to the x. For this one, your A is still positive, your B is a proper fraction. An example of that is half to the power of x. This exponential function shows you what happens when your A is negative. Now the B, which represents your increasing and decreasing, B is greater than 1. An example for that is negative 2 to the power of x and negative 4 over 3 to the power of x. The last exponential function, where your A is negative and your B is a proper fraction. An example of it is negative 1 over 2x. In conclusion, when A is greater than 0, we expect our graph to be drawn above the asymptote. When A is less than 0, we expect our graph to be drawn below the asymptote. Your B would either be greater than 1 or between 0 and 1, and it would definitely differ depending on the type of graph in which you have. How to sketch exponential graph. To sketch your exponential graph, a couple of things you will need to know. The first thing is to determine the shape. And the reason why I showed you those 4 examples is that before you start drawing anything, kind of have like a rough sketch of how your graph needs to look like. Right? It's going to model one of those 4 graphs. The second thing you need to do is find your x-intercept, your y-intercept, and the third thing you need to also find is your asymptote. It's only going to be the y-asymptote. So with those points, you should be able to draw your graph. And now, if you're still struggling, substitute 1 or 2 other points to help you make your curve look a little bit smoother. This example over here would explain how you should sketch exponential functions. So let's get into it. The first question says draw the graph of fx is equals to 2x minus 3. Now from this here, we automatically see that our asymptote is negative 3. Our y is equals to negative 3. So the first thing we can do is draw that. The next thing we're going to do is try to find our x and y intercept, right? Our x intercept would be so that's our x intercept. Our y intercept would be so now all we just need to do is plot this in. Now, before we draw our graph, we can think about our shape. And that's it. And as you can see, it looks like the curve we want. Come on. The next thing you definitely need to know is if you're now given the graph, how do you find exponential equations? So let's look at this example. It says the curve of an exponential function is given by fx is equals to k to the power of x, and cuts the y-axis at A, which is 0 and 1, and B lies on the curve, which is 2 and 9 over 4. Now we are asked to determine the function of f. We can write how we expect it to look. They told us that our function is going to look like this. If we put A as 0 and 1 in this equation, we're going to get this. Yeah, so it doesn't help me get my answers at all. Instead, I should substitute the other points, right? I'm going to substitute 2 and 9 over 4 into my equation. K will be 3 over 2. So our equation is fx is equals to 3 over 2 to the power of x. And that's it. Finally, on domain and range, the domain for an exponential function is always from negative infinity to positive infinity, while the range usually starts from your asymptote. If your graph is above the asymptote, is always from that till positive infinity. If your graph is below the asymptote, it's always going to be from negative infinity to the point of your asymptote. And that is it for exponential function. Now, this explains the most important things you guys need to know to understand exponential functions. We have other videos similar to this talking about linear, parabola, hyperbola. In the description below, we have like a function playlist. If you do enjoy it, please do give me a thumbs up, smash the like button, and subscribe. Thank you. Bye.